Hello again. In this video we're going to look at finding slopes from a table or given a table. Okay, so let's just review. If you want to, you could press pause and quick copy this down or just listen. Slope, again, asks the question, how quickly is our line or pattern increasing or decreasing? Okay, what's the speed at which our line is changing? What's the rate of change of our line or of our pattern? So in order to answer that question, we need two things. We need our delta y. We need our change in y, or how many tiles are we adding or subtracting. And we also need our delta x, or what's our change in x. How often are we adding that number of tiles? Okay, over how many figures? Okay, these two things get us our rate. And from that, our slope, which is represented by the letter m, equals our change in y over our change in x. Okay, so again, this was just a review. Our slope, which is represented by the letter m, is just the rate of change that measures how quickly is our line or pattern increasing or decreasing. And we calculate that by finding our delta y and our delta x and turning it into this rate, okay, into this speed, into that fraction. Okay, so there's a lot of different types of forms of a line, and we know this back from chapter 3. Okay, we could have a line that's given in a table, in a word problem, okay, in a graph, given a couple points. Okay, all these things are different representations of a line. Now, no matter what representation of a line there is, all lines have a slope. Okay, so we want to be able to find the slope of a line given any one of its formats. Okay, in this video we're going to look at what if we're given a table. So our first example, we just have an XY table. And we've seen XY tables before. Okay, we know, this could represent a line. And now we want to figure out, well, if we're given this table of this line, we want to know what is the slope of this line. So we want to know, find the slope. Okay, those would be the directions. So again, we need our delta y and our delta x. So our delta y, we ask ourselves, what's our change in y? Okay, how many tiles are we adding or subtracting through this table? Okay, so we see we're going from 5 to 12 to 19 to 26 to 33 to 40. So we're asking, well, how many tiles are we adding each time? Well, I know 5 plus 7 is 12, plus 7 is 19, plus 7 is 26, so our delta y equals 7. Okay, we're just adding 7 tiles. That's what this delta y equals 7 means. We're adding 7 tiles. Okay, now we don't want to get confused. We don't want to get tricked, okay? Because before, back in chapter 3, okay, when we only dealt with growth, okay, we might just want to say that our slope is 7. That's not really the case anymore. Slope is how quickly is our line increasing or decreasing, and we need these two things at this point. Because as we see, we aren't counting by ones in our delta x. We aren't adding 7 tiles each figure. We're not going from figure 0 to figure 1 to figure 2 to figure 3. Okay, we're going by something different. Okay, so our delta y equals 7 does not mean we're adding 7 tiles each figure. It just means we're adding 7 tiles. And now we need to ask ourselves, well, how frequently or how often are we adding those 7 tiles? Over how many figures are we adding these 7 tiles? So we want to know, what's our delta x? Well, we're going from figure 2 or from figure 0 to figure 2. So we added 7 tiles over 2 figures. We added another 7 tiles over another 2 figures. And we keep going every 2 figures. So our delta x equals 2. Okay, because we're kind of counting by 2 figures. So we added 7 tiles every 2 figures, and we added another 7 tiles over the next 2 figures. So that's what this delta x equals 2 means. We're adding 7 tiles every 2 figures. Now, if you remember from before that if we just have these two things, finding the slope is very easy. It's just the rate of change. If we're adding 7 tiles every 2 figures, that sounds like a speed. That's why we want to think of it this way. So we say our slope, which is represented by the letter m, our slope equals 7 tiles every 2 figures. So it's the fraction 7/2. Okay, there's nothing to reduce here. We're not going to divide and change it to a decimal, and we're certainly not going to change it to a mixed number. We just leave it as 7/2 because we understand what the 7/2 means. We're adding 7 tiles every 2 figures. Okay, and it is that simple. Whenever we're finding slope, we need our delta y and our delta x, and we just look at our table to figure that out, just like we did before, but now we just have to be a little more careful. We look at, we're adding, how many tiles are we adding each time? We could easily see that we're just adding 7 tiles each time. And we go to our delta x. Well, are we adding them every figure, every 2 figures, every 3 figures? So we look at, what are we counting by for our figures? What's our x's counting by? What's our change in x? And that's plus 2. Okay, next example. Okay, we want to find the slope of this line. Okay, so we have our new table. It says find the slope. The directions are to find the slope. So we need our delta y and our delta x. So our delta y is how many tiles are we adding or subtracting? Well, here we see that we're subtracting tiles because we're losing tiles each time. Our delta y is decreasing. Okay, and we ask ourselves, well, what are we subtracting by? Well, we're going from 12 to 11 to 10 to 9 to 8. So it's obviously we're just subtracting 1. Okay, from 12 to 11, we're subtracting 1 tile. From 11 to 10, we're subtracting 1 tile. From 10 to 9, we keep subtracting 1 tile. We're spending $1 or losing £1. We're subtracting 1 tile. Now again, we don't just want to say our slope is -1. That's not the case at this point in the year. We want to figure out, well, how often are we subtracting 1 tile? Is it every figure? Is it every 2 figures? Every 3 figures? Or so on? We need this delta x. Okay, how frequently are we subtracting 1 tile? How frequently are we spending $1 or losing £1? So we're going from 1, for our x's, we go from 1 to 5 to 9 to 13. So we see that we just keep adding 4. We're going every 4 figures, or every 4 weeks, or every 4 days. Okay, so our delta x equals 4. We're going from day 1 to day 5 to day 9, or from figure 1 to figure 5 to figure 9. Okay, so we're subtracting 1 tile every 4 figures. Okay, or we're losing £1 every 4 days. We're spending $1 every 4 cookies. Okay, this is what a slope is. It's just a rate of change. And we always just refer back to our tiles because that's what we learned first of all. Okay, so we're subtracting 1 tiles every 4 figures. So our slope, again, it's represented by the letter m. Again, don't ask why, just accept it, is -1 over 4. And it's very important that we keep this negative. That negative means we're subtracting 1 tile, we're losing £1, we're spending $1. Our line is decreasing. That's why we need to keep our slope as being negative. It's always a good question to ask yourself at the end. Is your line increasing or decreasing? Is the pattern increasing or decreasing? If it's increasing, then this needs to be positive. If it's decreasing, then our slope needs to be negative. In this case, we see that it's decreasing, so our slope has to be negative. Okay, let's look at one more example together before you try some on your own. Again, our directions are find the slope. So we want to find the slope of this line. We want to know how quickly is this line changing. So automatically when we see find the slope, we need these two things. We need our delta y and our delta x. Okay, our delta y, again, we ask ourselves how many tiles are we adding? Okay, how many pounds are we gaining? How tall or how much is the tree growing? These are the questions that we ask ourselves. We want to know our delta y. Well, we see our delta y's, our y's are changing by adding 4. So we're adding 4 tiles. Now we want to know how often are we adding those 4 tiles. We're going from figure 12 to figure 18 to figure 24 to figure 30 to figure 36. So we're adding these 4 tiles every 6 figures. Again, we think of this way to understand that the slope is really just a rate of change. Adding 4 tiles every 6 figures sounds like a speed, so we say our slope equals our delta y. We're adding 4 tiles every 6 figures, so our slope is 4 over 6. Now, in this case, we could see that this reduces. Again, we aren't dividing 4 divided by 6. We're just reducing this as a fraction. Okay, and 4, 6, adding 4 tiles every 6 figures is the same as adding 2 tiles every 3 figures. And this is our slope. Okay, so why don't you try a few on your own. You know the drill by pressing pause, trying them, and pressing play when you're ready to check your work. Okay, so copy these down, try these 3, then press pause when you're ready to check your answer. Or press play again when you're ready to check your answer. Okay, so our first example, again, we're finding the slopes. We need our delta y and our delta x. Our delta y equals 3 because we're adding 3 tiles, and our delta x equals 5. Okay, because we're going from figure 0 to figure 5 to figure 10. So our slope is, we're adding 3 tiles every 5 figures, so our slope is 3/5. Our second example, okay, we need our delta y and our delta x. So our delta y is, we see that we're subtracting 2 tiles, so our delta y equals -2. And we're subtracting 2 tiles every 4 figures, so our delta x equals 4. So our slope equals -2 over 4, and this can reduce to -1/2. Okay, we're subtracting 1 tile every 2 figures. And our last example, okay, delta y equals 2. We're adding 2 tiles. Delta x equals 2 as well, because we're counting by 2's for our x's, so our slope is 2 over 2. We could reduce this to 1 over 1, which is just 1. Okay, if we're adding 2 tiles every 2 figures, it's the same as adding 1 tile every figure. And if we always have that every figure, if we could reduce it to be like 1 over something over 1, it's just that whole number. Okay, 2 divided by 2 equals 1. So our slope is 1. Okay, great.